Hello children, welcome to the science class. Today we will read about chapter 11. So dear children, kindly open your book, page number 114. Chapter 11, Work and Energy. Children, from this chapter we will learn about work, simple machines, type of simple machines, energy, sources of energy, various forms of energy, change of form of energy, conservation of energy. So first we discuss about work. Work is the application of a force over a distance. Lifting a weight from the ground and putting it on a shelf is a good example of work. The force is equal to the weight of the object and the distance is equal to the height of the shelf. A force is said to do work when it acts on a body and there is a displacement of the point of application in the direction of the force. Children, what is displacement? Displacement means the action of moving something from its place or position. Okay? For example, when you lift a suitcase from the floor, there are two forces that do work. The normal force by your hand and the gravitational force. If the force acting on an object does not move it, no work is said to be done, means no displacement is there. Thus, work done equal to force multiply distance traveled. Children, you remember work done equal to force multiply distance traveled. There are two things to work, force and the displacement in the direction of force. In order for a force to work on an object, there must be a displacement and the force must cause the displacement. There are several good examples of work that can be observed in everyday life. They are the horse pulling a tonga on the road, a shopkeeper lifting and putting the articles in his shop at proper places, a student lifting a bag full of books upon his shoulder, a weightlifter lifting a barbell above his head. In each case described here, there is a force exerted upon an object to cause that object to be displaced. Now think of this situation. A man applies a force to a wall and becomes exhausted. This is not an example of work. The wall is not displaced. A force must cause a displacement in order for work to be done. Simple machines. A machine is a tool used to make work easier. Simple machines are simple tools used to make work easier. Compound machines have two or more simple machines working together to make work easier. Then types of simple machines. There are 6 types of simple machines. They are lever, pulley, inclined plane, screw, wedge and wheel and axle. First we discuss about the lever. When you find it difficult to open the lid of a tin, you can use the handle of a metal spoon to lift the lid open. The spoon makes it easier for you to open the tin. Thus, spoon is a simple machine. If you are asked to move a big piece of a rope, find a long stick and a small stone to help you to do the work. The stick helps you in the same way as the spoon, so it is also a simple machine. Levers are one of the basic tools that were probably used in early days. A lever is a stiff bar that rests on a support called a fulcrum, which lifts or moves loads. Many of our basic tools use levers, including a pair of scissors, peelers, hammer claws, nut crackers, and tongs. The force that we use on the lever is called the effort, and the weight that we try to move is called the load. The point of support on the lever that does not move is called the fulcrum. Clear? Depending on the relative positions of the effort, load, and fulcrum, levers are classified into three classes: class 1, class 2, and class 3. So first we discuss about levers of class 1. A lever in which the fulcrum F is in the between the effort and the load is called a lever of class 1. For example, a seesaw, a pair of scissors, a nippers, a nail cutter, and a hand pump. Then levers of class 2. The levers in which the load is between the fulcrum and the effort are called the levers of class 2. In these levers, load is in between the fulcrum and effort. For example, bottle openers, wheelbarrows, and nut crackers. Then levers of class 3. In a lever in which the effort is between the fulcrum and the load is called a lever of class 3. For example, forceps, fishing rods, and tongs are the example of lever of class 3. The pulley. A pulley is a grouped wheel or a combination of grouped wheels. It consists of a wheel with a grouped wheel with a rope or chain on the group. It is used to lift heavy loads. The force is applied at one end of the rope while the other end of the rope holds the load. The pulley rotates on its axis. There are two types of pulleys: fixed pulley and movable pulley. Fixed pulley is one fastened by means of hook to some support. We gain in direction as well as in force with its help. The simplest type of pulley is the single fixed pulley. It is most commonly used on flagpoles. A flag is tied to a rope which goes round the pulley. This pulley is fixed to the top of the flagpole by pulling the other end of the rope downwards. The flag is raised. It is also used to draw water from a well. Then movable pulley. A movable pulley is fastened to the load. A compound pulley is a combination of fixed and movable pulley system. Then inclined plane. The inclined plane is a flat surface with one end higher than the other. A road up a hill is an inclined plane, and so the slide in the park. The inclined plane is usually used to lift heavy objects. A small effort is required to raise a heavy loads. But as in the lever, the effort has to travel a greater distance than the load. Whether the inclined plane is long or short, the amount of work done is the same. But it is easier to move the load over a larger distance. An inclined plane does not make work less but makes the work easier. If a mountain is very steep, a car cannot climb up. In such cases, we cut a winding road into the mountain. The car can climb such a road. The winding road is in fact an inclined plane. However, is not shaped in a straight line. Is a zigzag manner. Then the wheel and axle. You must have been seen a lot of things around you which make use of wheels. Your bicycle, cars, buses, etc. all uses wheels to move. The wheel itself is not a machine, but it becomes a machine when an axle is combined with it. The axle is a second wheel fixed tightly to the first so that they run together. A wheel and axle is another simple machine. Wheel and axle arrangements are used to lift the loads. How heavy a load the effort can lift depends how many times the wheel is larger than the axle. In places where there are wells, the wheel and axle arrangement is used to raise water from the well. The bicycle is another example where wheel and axle is used. Egg beater and steering wheel of a car are also examples of wheel and axle. The screw. The screw is an inclined plane wrapped around a rod, cylinder or pole. Screws are commonly used to hold things together, but large screws can be used to lift cars and other heavy loads. When a screw is turned once round, it advances a distance equal to the space between two neighboring threads. This distance is called the pitch of the screw. The vase. The vase is one of the simple machines from which many more complex machines are derived. The vase works on the same principle as the inclined plane. You should have seen woodcutters and carpenter splitting blocks of wood using a vase. The edges of an axe, a pen knife, a chisel, a blade and a razor are all wedges. All these tools help us to cut things easily. The vase has two inclined surfaces joined together back to back. The carpenter keeps the vase on the block of wood and strikes the flat portion of the vase with a hammer. He strikes it repeatedly and the wood splits. Energy. Energy is defined as the ability to do work, and work is the transfer of energy from one form to another. In this sense, examples of work include moving something, lifting something, warming something, or lighting something. In practical terms, energy is what we use to manipulate the world around us, whether by using our muscles, by using electricity, or by using machines such as automobiles. It is difficult to imagine spending an entire day without using energy. We use energy to light our cities and homes, to power machinery in factories, cook or food, play music and operate our TV. So it is difficult to live without energy. Then sources of energy. An energy resource is something that is used to provide energy. There are lots of different energy resources. A tree needs energy to grow. Our body needs energy to work and play. A car needs energy to move. Where does all this energy come from? The sun is an energy resource for trees and plants, but all of our energy actually starts off coming from the sun. Think about when you ride your bicycle, where does the energy come from? This energy comes from the food that you eat. The food you get from plants and animals. Plants use sun's energy to make food. Thus, the sun is the main source of energy. Other sources of energy are wind, water, fossil fuels. Okay. Various forms of energy. There are two types of energy: stored or potential energy and working or kinetic energy. For example, the food we eat contains chemical energy, and our body stores this energy until we release it when we work or play. First, we discuss about stored or potential energy. Potential energy means, children, it is stored, okay, and the energy of position gravitational force. It exists in various forms. First one is chemical energy. This energy is the energy stored in atoms and molecules. Biomass, petroleum, natural gas and coal are examples of stored chemical energy. Garbage, industrial waste, sewage, cow dung and other waste materials form biomass. Biomass is decomposed in the absence of oxygen to produce methane gas, which can be used as a fuel. The residue can be utilized as a manure. Cover gas plants are becoming popular in our villages. Then nuclear energy. This energy is also the energy stored in an atom. The uranium atom is an example of nuclear energy. This energy binds the nucleus of the atom together. On splitting, it produces a large amount of energy. Then stored mechanical energy. Stored mechanical energy is energy stored in objects by the application of a force. Compressed springs and stretched rubber bands are examples of stored mechanical energy. Then gravitational energy. The gravitational energy is the energy of place or position. Water in a reservoir behind a hydropower dam is an example of gravitational energy. When the water is released to spin the turbines, it becomes motion energy. Kinetic energy. Kinetic energy is the energy in motion. The motion of waves, atoms, molecules and substances. It exists in various forms. They are radiant energy, Solar energy is an example of radiant energy. Then thermal energy. Thermal or heat energy is the internal energy in substances. Geothermal energy is an example of thermal energy. The variation and movement of atoms and molecules within substances also give thermal energy. Then sound energy. Sound is the movement of energy through substances. Then electrical energy. Electrical energy is the movement of electrons. Lightning and electricity are examples of electrical energy. Change of forms of energy. The following is an example of the transformation of different types of energy into heat and power. The car or bus which brings you to school gets its energy from petrol, diesel or CNG and a battery. A petrol, diesel or CNG stores chemical energy and the battery stores electrical energy. The engine changes this chemical energy and electrical energy into different types of energy, such as when the engine starts, we switch on the radio or beep the horn, we can hear it. This is sound energy. When it is dark, we switch on the headlamps. This is light energy. After the car has been running for a while, the bonnet becomes warm. This is heat energy. Heat energy is always produced when things work. When you run about, you get hot. When we drive about, the car is moving. This is mechanical energy. So children, you remember, energy can change from one form to another. It cannot be created or destroyed. Conservation of energy. We are mostly dependent on fossil fuels for our energy requirement. Fossil fuels are non-renewable resources of energy. Their stock is limited. One day we shall exhaust them all. So, we must learn to preserve the available sources of energy. We should economically use fossil fuels. We should not waste electricity and fuels. We must find alternative sources of energy. We must make use of renewable sources of energy like the sun, water, wind and biomass. The use of renewable sources of energy will not only reduce our dependence on fossil fuels but also help in reducing pollution. Okay. So children, this is about your chapter 11, work and energy. Again, you read this chapter at your home and it will be easy to you to learn the question answer. Thank you.